Hi, I'm Sulaiman Mohammed Kamaluddin. My matrix number is BE31720. I'm from Group 5 project. I'm here to explain a bit in our group report. Firstly, introduction. DC brush motor is an electrical component which commonly used in industrial applications. Because it's easy to be controlled, the industrial applications that being applied with DC brush motor are powered by battery. Battery acts as a voltage can control it to a vary speed of DC brush motor. We can adjust the speed of an armature winding motor by alerting the applied voltage. This is referred to as armature voltage control. To determine the rotor speed, the applied voltage was adjusted and changed. Secondly, methodology. This project is based on Chapter 6, Simple Linear Regression. In this project, we learn more about the graphical method to draw the scatter plot in the Excel software. Least square method is about the equation of regression line in the scatter plot. The Pearson correlation is used to determine the strength and direction of the linear relationship with two variables for one two-tailed sample. The t-evaluate was the data that analyzed using Excel assessed the R-value between hypotheses. How the data is obtained. The data is obtained from the quarters second software, which used to design the switching scheme through the failed programmable gate array (FPGA) board made by Intel Alert. To solve all the problems that arise, we can employ a variety of ways. The purpose of this project was to come up with the cost estimate. With a cost estimate, the connection between the router speed and output voltage, because it had an impact on the output voltage, is an independent value from the router speed.
Assalamualaikum and good morning. My name is Nur Fazna binti Muhammad Idris, CE 190107. So now I'm going to present about result discussion. So for the result discussion, I'm going to cover several parts. So for the first part is mean, standard deviation, minimum and maximum value for the independence and dependence variable. So we can see here the total number of data is 100, and the minimum value for speed is 0, and minimum value for voltage is 0.24 volt. The maximum value for the speed is 6970x.70x.23, and for the voltage is 24 volt. So we can see here the value of mean for speed is 2446.0857, and for the voltage is 12.12, and for the standard deviation for the speed is 2069.83, and for the voltage is 6.96. Okay, as you can see here, for the mean and all, so I'm going to show for the mean first. For the mean, I've done in Excel, and I got the exact value as the Excel. So next part is scatter diagram and regression line for the data. For the scatter diagram and regression line in data, I'm going to show you by using Excel. So here's my graph. The blue dot is for the scatter diagram, and for the red line is for the linear regression line. So you can see here, based on the graph, the value of y is obtained as 297.24x, negative 156.43, and for the r value is 0.9998, which is equal to 1. So, as you can see here, I've mentioned already in the report. And then I'm going to the next part, which is assuming a linear relationship. Use the least square method to find the simple linear regression model. Okay, here I've done screenshot it, and in the Excel, let me show you. In the Excel, I've done it. Here's a, sorry. So here is the summary output when I do the data analysis. Okay, in the data analysis, we can see the value of R square, the value of regression residual, the significant, and for the intercept coefficient. So, okay, as we know just now, the value for y is here 297.24x minus 156.43. So this value is I obtained from the Excel. So when I do the manual calculation, I get the exactly same result as the Excel. So here's the manual calculation. I've shown it in the report. I've shown it by every step, and for the final answer, I got the same as the Excel. So for the next part is the check the significant equal to 0.05 of the simple linear regression model in C. Okay, and this I just take from the data analysis from the Excel. Here is it. So the significance is 3.6391 exponent negative 180. When I put it in the calculator, I convert it to the whole value, whole number. I obtain as 0.0000. So I just so it means that the value is 0.00. So the significance is 0.00 and it's lower than 0.05. So you can see that the simple regression linear model is significant. The next part is interpret the meaning of the intercept and slope in this problem. Please comment any impossible event. So as you can see here, based on the graph, the increasing the number of voltage, then the increasing the number of the value of speed. So we can expect the increase of both of the value, but we cannot get the answer for the negative value because the at the slope the we obtain negative 0.156.43. So the intercept cannot be interpreted. So that's all from me. Thank you.
Hi, my name is Nanabia binti Muhammadiyah, and I will my metric number CE190179. So I will explain about the test, the hypothesis H1, which is 1.3.6. The hypothesis can be tested by the formula where beta 0 is constant, beta 1 is slope or regression coefficient, y is independent, x is dependent data and error. So for the step 1, we state the hypothesis, which is alpha equal to 5%, alpha equal to 0.05, and we divide by 2, we get 0.025. Step 2, we write the information, which is this is the two-tail test, and by using the t-table, and we get the V is equal to 98 and TC equal to plus minus 1.980. So the decision rule, we reject the H0 if the t-test falls in the rejection region, where negative 1.980 less than TC or more than. For the step 3, we compute the MSE and the t-test by using the value of sum of x, sum of y, x power of 2, y power of 2, and sum of x multiple y. We get all the answer from the Excel, and n equal to 0. So first we need to calculate the SXY by the formula, and we get the value answer 1426596.255, and we then calculate for SXX and SYY. This is the answer we get, and then from the answer of SXY and XXX, we find the regression coefficient which is beta 1, and we get the answer. Then we found the y-intercept, which is beta 0, using the formula, and we get negative 156.4289. And then we need to find the SSE and MSE, which is we get the answer for SSE in 97279.4878 and MSE 992.6478. Then we need to find the t-test 1, which is beta 1 minus beta c equal divide by power root MSE divided by SXX, and we get the answer 653.5886. Next, we find the t-test 2 using the formula and put all the data, and we get negative 18.2902. So step 4, we reject the H0 because the t-test 1 more than TC, which is more than 1.980, and t-test 2 is less than 1.980. So lastly, we can conclude that the E beta 1 slope can be equal to 0. That's all from me. Thank you.
Good afternoon. My name is Nisha binti Al-Halil, and now I will conclude the coefficient of Pearson correlation and interpret the meaning. First of all, Pearson correlation is about measure the strength and direction of linear relationship between two variables. In our assignment, we use output voltage and speed. Okay, first we must know the formula Pearson correlation. R equal SXY divided by SS times XYY. Okay, so firstly we must find the value for XY, XX, and also YY. Okay, next we insert the value into this formula, and we get the value for correlation, Pearson correlation 0.999 and 85609. Okay, so based on the value for baseline correlation that we get, we conclude that the result shows strong positive linear relationship between the output voltage and speed. Okay, so next I would like to present about compute the coefficient of determination and interpret the meaning. Okay, in this section, in this part, I will show how to make comparison between simulation and also manual calculation. Okay, based on our data simulation, we get the value for R squared 0.999770744. So we do manual calculation, and this is the formula for R squared, and then we insert the value for SE and YY, and then we get the value similar compared with the simulation, which is 0.999777064. So we conclude manual calculation and simulation, it shows the value between both methods almost the same. So we also can conclude that the result show strong positive relationship between output voltage and speed. Next, conclusion. Okay, the conclusion for our assignment. We know how to estimate the relationship between the voltage and speed. Okay, we also know how to divide independent variable and also dependent variable. And then regression line, we also get where we do the simulation in Excel software. And for Pearson correlation, we also get in manual calculation and also data simulation. The value is similar, so there's no difference between the formula between the result. So conclusion, relationship between the two variables have been shown in calculation and drawing graph. So like I said in correlation Pearson, our assignment, data simulation and calculation, both show a strong positive linear relationship between output voltage and speed. That's all for me. Thank you.